We are now going to look at Lesson 3 in Chapter 10, Video 4, the sum of a geometric series. Here I have the sum of a geometric series. Does it really have a sum? After all, it goes on forever. Well, as it turns out, geometric series, if the common ratio is less than 1, does have a sum. And the sum is found by taking the first term and dividing by 1 minus the radius. So for this one, I can find the sum. 4/5 is the common ratio. All I need to do is find the first term. So the first thing you do is find the first term. And 1 minus 1 is 0, so that's 5, because this makes this 1. So I know the first term is 5. So now the sum is equal to 5 over 1 minus 4/5, which is 5 over 1/5. Invert and multiply, and you get 25. So the sum of this series is equal to 25. Note, 1 plus 1/2 plus 1/4 plus 1/8 has a sum because the common ratio is 1/2. 5, 10, 20, 40. You can clearly see that these are going to continue to infinitely large, so there is going to be no sum, and that always happens because the ratio here is 2. Anytime the ratio is more than 1, it will increase infinitely large. Let's look at a couple of other samples to help you get the feel for how to use this formula. So here's the formula. Let's look at the first one. N goes from 1 to infinity of 3 times 2/3 to the n minus 1 power. All right, well, now we have to find the first term. A sub 1 equals, let's see, putting a 1 for n, 1 minus 1 is 0, which means this is 1, which means the first term is 3. The common ratio is 2/3. So this will equal 3 over 1 minus 2/3, which is 3 over 1/3. Invert and multiply, the sum will be 9. Let's take a look at another one. All right. On this one, let's first of all see if we can find the first term. So A1 will be 20 times 1/2 to the first. Notice it's not n minus 1, it's n, so it's to the first power. So this gives me 20 times 1/2, which is 10. So the first term is 10. Common ratio is 1/2. So according to the formula, this will be 10 over 1 minus 1/2, which is 10 divided by 1/2, invert and multiply, and you'll get 20. This should give you an idea of how to handle sums of infinite geometric series, and this finishes lesson 3.